Hello, welcome to this lesson of Algebra 1. We're going to talk about solving formulas for variables, and that's kind of a weird sounding title. And here you're going to finally be able to use some of the things that you've learned in algebra for something really, really useful. So for instance, let's talk about the concept of what a formula is. Here's a formula that you've probably seen somewhere in your studies. C is equal to 2 pi times r. What do you think that means? Now, some of you may or may not have seen this, but most of you probably have. And it is the formula for the circumference of a circle if you know its radius. So if you have a circle and you know its radius, then you take whatever that radius is times 2 times pi, and then that gives you the distance all the way around the circle, the circumference. So here's the deal. If you know the radius, you stick it in here, multiply it by 2 pi, you get the circumference. That's great. But what if you want to go backwards? What if you know the circumference of the circle and you want to calculate the radius? How do you do that? Well, see, this formula is called a formula because it's set up to calculate something. So you plug in the stuff on the right-hand side and it calculates the stuff on the left. But what if I asked you, what if I said, hey, solve this formula for r? Now, before algebra, you'd have no idea how to do that. If I gave you the circumference and you want to calculate and solve for r, you wouldn't know how to do that. But now you actually know enough to do that. So let me ask you this. If I want to solve for r, how do you do it? You want to get r by himself on both sides of the equal sign. Now r is over here with 2 times pi times r. So how do you get rid of the 2 and the pi? Well, let me rewrite everything kind of underneath so I don't, kind of destroy what I've written above. 2 pi r. Well, what I can do, since this is basically multiplication going on over here, I can divide both sides by 2 pi. 2 times pi is what you're doing, 2 times pi. Right, because I can do anything I want to the left and the right-hand side. Now, on the right-hand side, the 2 is going to cancel with the 2, dividing to 1, and the pi is going to divide here, giving you 1. All right, so what you're going to have is c over 2 pi is equal to r. So you've actually done everything in one step, or another way to write that is r is equal to c over 2 pi. So now you see what you've done is you've taken the original formula that is the one that you always see in books, and you have solved it for the variable r. Now you have a new formula which is directly related to the old one, but this one is if I've already given you the circumference, the distance around the circle, all you do is you divide by 2 pi, and then you've calculated its radius. So you've kind of solved the formula for another variable that's inside that's very, very useful because sometimes maybe you were given the circumference and you really do want to calculate the radius. All right? And you have to use the rules of algebra to get here. So in this case, it was multiplication going on here, so we divided to get rid of this stuff, giving r. So it's easier to continue solving these than kind of see the point here. Here's another famous formula you may or may not have seen. F is equal to ma. So this is from physics. This is force is equal to mass times acceleration, and it basically talks about motion. If you push on something with a force, or actually let me back up and start the other way. If you know how much something is accelerating and how much mass it has, if you multiply those two together, then this is how much force you must be applying to make that acceleration happen. So, but what if you wanted to solve this for a, the acceleration? Then how would you do that? So here you're calculating the force when you're given the mass and the acceleration. How do you solve for a? Well, again, this is multiplication going on. So let me rewrite everything. F is equal to ma. If I divide the right-hand side by m, then I have to divide the left-hand side by m. The masses are going to cancel on the right-hand side, and so I can rearrange it and say a is equal to f over m, just flipping around the equal sign, and that's the final answer, right? So now if you know the force that you're pushing on an object and you divide by the mass of that object, this is going to tell you how much is accelerating or how much acceleration you're going to produce from that force. So this section is all about solving formulas and trying to figure out and solve for other variables. So this is a formula that you've probably seen. E is equal to mc squared, right? So this is Einstein's famous formula. And what this basically means is if you know the mass of something, then you multiply by the speed of light. That's what c is. It's the speed of light squared. So it's the speed of light times the speed of light times the mass of the object. This is basically a measure of how much energy is contained in any mass that you have. If you know the mass of a coffee cup and you multiply by the speed of light squared, this is how much energy is contained inside the atoms. This is where nuclear energy comes from, the energy inside of the nucleus of the atom, inside of the entire atom. But what if I wanted to solve this for m, right? Maybe I want to rearrange it. So I can do the same kind of thing. If I want to solve for m, I need to divide by c squared on the left, and then also on the right, I have to do it to both sides. So c squared is going to cancel with c squared. And at the end of the day, m is going to be equal to e over c squared. So what you're getting in this case is, if you know the energy contained in the atoms, divide by the speed of light squared, then you're calculating the mass of the object. And we can just continue cruising on down here. So let's do another problem. Let's say area is equal to 1/2 base times the height. Now let's say we want to solve for b, the variable b. So in this case, we're calculating the area of some object based on its base and height, and then the fraction 1/2. Now we want to solve for b. So there's a couple of different ways you can do it. You can do it in one step or multiple steps. Let's just do it in multiple steps. Let's go ahead and first rewrite everything. A is equal to 1/2 b times h. Now we want to get b by himself, so let's first divide the right-hand side by h, and then we have to do it to the left-hand side. So that cancels h with h. And so now what I'm left with on the left is a over h is equal to 1/2 b. Now, how do I get rid of the 1/2? Now, if I multiply both sides by 2, then on the right-hand side, the bottom 2 and the bottom of that fraction cancels with the 2 in the top right there. And so what you're going to end up with is going to be b is equal to 2a over h. And that's the correct answer. So you see how we're taking a weird-looking formula that solved for a, and we can use the rules of algebra to solve for any variable we want. Now if we know the area and the height of the thing, 2 times the area divided by the height is going to give us the variable b. All right? So let's go and just do a couple more here just to give you some additional practice. What if you had, this is an interesting one, something that you may not have seen, but it's very useful. C is equal to 5/9 times f minus 32. This is the formula so that if you know the temperature of something in Fahrenheit, you can convert it to temperature in Celsius. So you take temperature in Fahrenheit minus 32, take that whatever number you get, multiply by 5/9, and then that gives you the value in Celsius. But what if you want to solve for f? F is wrapped up inside of here, so we have to think about how can we go about unwrapping this puzzle and solving for f. First thing we need to do is deal with the fraction on the outside there. So let's go ahead and rewrite everything. C is equal to 5/9 f minus 32. All right? And then we're going to have, if we want to cancel the 5 on the top and the 9 on the bottom, we can multiply by anything we want. We can multiply by 9/5. So we have to do that to the left and to the right. Now make sure you understand why, because the top 9 will cancel with the bottom 9, the top will cancel with the 5. So basically that's a good way to get rid of the fraction, multiply by the reciprocal. So what you're going to have is 9/5 times c on the left, and then you have f minus 32 on the right. Now how do you get f by himself? So since this is subtraction, we need to add 32 to both sides. We need to add 32 to both sides. So 9/5 c plus 32 is equal to f. So we just add 32 to both sides. It goes away on the right, goes to 0, and on the left we just simply have it added here. So f is equal to 9/5 c plus 32. So here's the deal. If you know the Celsius temperature of something, you can plug it in here, multiply by 9/5, and then add 32, and that's going to give you the Fahrenheit number. If you already had the Fahrenheit number, you would use this equation to go back and calculate c. So there's lots and lots of ways to do things here. Now I want to do one more. This is a really useful formula. You use that in chemistry all the time. I want to do one more, and this one's a little bit more complicated, but I'm just showing you that no matter how complicated they get, you can always unwrap it and use the rules of algebra to get what you want. So you have capital F is equal to little f times g over f plus g minus d. Now this is kind of a nonsense formula, you know, it doesn't really mean anything, but you could define it, and you want to solve for the variable d. So right now this equation calculates capital F. You put in little f here and little g and little d, and you do this math, you're going to calculate something called big F. Now let's solve this thing for little d. How do we do that? So we need to first, we have to unwrap this puzzle. So here, the only place d exists is in the denominator of this fraction. So we need to get them out of the denominator, but we can't just multiply by d. We need to multiply by the entire denominator to cancel it on this side. So let's just go ahead and rewrite everything. Is fg over f plus g minus d. If we want to cancel that entire denominator and get it out of there, we need to multiply on the right by f plus g minus d. And then on this side, we can do it lots of different ways. I kind of didn't leave enough room, so I'll just write it here. F plus g minus d. Sorry, that's a little bit cramped over there, but that's basically what's happening. So on the right-hand side, the entire denominator cancels with this. And on the left-hand side, we have to distribute this Fn to this capital Fn to each place. So what's going to happen here, let me switch colors here, is f times little f is going to be capital F times little f, and then capital F times g, so plus capital F times g, then capital F times negative d, which is negative capital F times d. Now on the right-hand side, the denominator here canceled with this, so it's gone. All we have really there is little f times little g. So even though that kind of looked nasty at first, now everything looks a lot easier. You see, because here the only place d exists is right here. So we have to move this term over here, and then we're halfway there. So in order to move this term over here, we subtract capital F times little f from both sides, and then we can also subtract this term from both sides. So what you're going to get is negative fd is equal to fg minus ff minus fg. Make sure you understand, I subtracted ff from both sides, so it disappears here, and it shows up here as a subtraction on the other side. I subtract this term from both sides, so it disappears, and it shows up as a subtraction on the other side. Now all I have is this. I don't like the negative sign, I don't like the capital F. So I divide by negative f. And I have to divide the other side by negative f. So at the end of the day, d is going to be equal to, now I have a negative sign here in the bottom, so there's a couple ways to handle that. Well, let's just go ahead and do it like this. You can bring the negative sign up here, negative, and you have fg minus f, whoops, let me go back and subtract that. Capital F minus capital F, G over F. All I did here is D is isolated. Let me go ahead and cancel these. That's canceled with that. D is the only thing on the left-hand side, right? So this is the answer. This is effectively the answer. And this negative sign that was on the bottom, when you have a negative sign, it can float out in front of the fraction. That's either way, it's fine. You could leave the negative here, or you could leave it out in front. Or you could actually take this negative and move it to the top. So if I wanted to, I can multiply negative times each one of these terms, and that would make it the following. D is equal to negative FG plus FF plus FG over capital F. So let me double check that. Negative FG plus capital FF plus capital GG over F. This is the right answer. Also, the thing above it is the right answer. I mean, there's really no way to write it. This is a fine way to do it. This negative can go in and negate everything, distribute in just fine. So that was kind of a complicated equation, mostly just to show you that it doesn't matter how complicated they are. You can always use the rules of algebra to isolate any variable you want. Here we were solving for D. I could go and solve for G if I wanted to, or little f, or whatever I want, and that's really useful because in physics or chemistry, when you get down the road, you'll be given a formula, but many times you have to rearrange the formula or rewrite it so that you can solve for what you need for your problem. So make sure you understand this. Follow me on to the next section. We will switch gears a little bit and talk about factoring numbers.